Hi everyone, welcome to SD7 Learnings. So down the line we are going to know about Catia V5 and those workbenches. So here I'm going to give a demo regarding the Catia V5 and its workbenches. Catia V5, the full form of Catia is Computer Aided Three-Dimension Interactive Application, which means that by using the CAD tool, we are going to interactively design the models. And V5, which means that it's version 5. So every year, if you can see, the developer of Catia is known as the Dassault System, which is a French-based company. And basically, they have created the software for the defense purpose, and later it was open for the public to be used. So the Catia is now widely used throughout aerospace and as well as automotive industries. So coming to the topic, version 5. So every year, based on the requirements, the Dassault system would collect data from different manufacturers and the companies, where those data with respect to what kind of features is mostly used and what kind of improvements needs to be done to make the product more effective. So based on these comments and the inputs from those companies, uh, the data has been gathered, and the Dassault system will consolidate all those data, and they come up with the next version of Catia, which is known as version V5. Currently, we are in version V5, and it goes to the version V6 and goes on. So in Catia, every time a particular see where I have experience of around 18 years, and I've been supporting in troubleshooting Catia software related issues. Once I've been sent to the client to where I was to sort out an error where a particular model of ball bearing has been designed, and while trying to project a view on it, the Catia was not able to recognize in the background and generate a view. We can see just a X mark on the view, and it was so difficult to find out how to rectify this issue. And down the line, we worked on the background, and we found that a particular shape in the model, which is getting difficult for the Catia to recognize and develop the generate the view. So after designing the same feature in different command, the view was generated. So that input was taken from the client, and it was added in the next release, which is a release every time a pack. They used to call build release pack. So every depends upon the service pack. 3 months or 6 month once service pack will be released, and those datas, those improvements are incorporated in the software. So this is a basic general idea about the Catia V5. And now let's come into the Catia 2. So here, this is the Catia interface, which looks like this. And here we have a start button. And in the start button, we can see there are so many workbenches. So these are known as the workbenches. So here in the infrastructure, we have so many workbenches where we can see a product structure, how to maintain a product structure in a particular industry, and the material library. A particular company may have different type of customized materials, so those materials can be added in this library, and later it can be incorporated in the model which we design. And this is the compatibility of Catia V4, V3, and V2 we can do in this area. catalog editor where the standard parts like nut, bolts, screws, and when it comes to the electrical, the connectors, the batches, and sort of things can be added in a library, and it will be handy to take it out during the design phase or in the assembly line. So, in such a way, the photo studio where the model has been rendered for a better realistic image of it. So, such kind of modules, workbenches are available over here. And in mechanical design, we can see the part design where the parts have been designed here, and those parts have been taken to the assembly design workbench where each and every part has been assembled in the assembly workbenches. So sketcher is the core area where the initial sketch has been done, and it has been generated into a 3D shape by using the part design workbench. Product of function and tolerancing annotation. So in order to nowadays, in order to minimize the usage of a drawing, we can produce the engineering drawing data in the 3D itself. So we can use product functional tolerance and annotations. These are the two modules where we can do for assembly as well as the particular part, well design and mold design workbench. So here we have the drafting where the 2D, the once the model has been designed, the 2D drafting takes place over here. And we have the sheet metal design where sheet metal components are being designed by using this workbench. And composite design nowadays, we can see mostly it's being used in the aerospace and the automotive industries where majorly it's being used. And generative sheet metal design, wireframe and surface design where the surface of the contour shapes are being designed in using these workbenches. There are n number of workbenches over here, and down the line we can go one by one, which is highly used in the current market scenario. When it comes to the shapes, so these are the shapes where the, for example, let's say the car body and the aircraft bodies have been designed by using these generated shape design workbenches. So there are different classes of surfaces. So those things is and all, it's been used over here. Analysis and simulation where the simulation activity would be taken place by using these workbenches and finding out what is the stress activity with respect to the model we design. In this workbench, we can even design a plant layout and how, what kind of plants, and within that layout, how, where a machine shop needs to be there, and the plant layout with respect to the regulations can be designed here. And here in the machining, we have so many workbenches where the lathe machining parts which has been designed, it's been taken to this area, and it's been simulated how the each and every operation would be carried out. When it comes to the digital mock-up, we have space analyzers, navigator, and a kinematic, such kind of workbenches where, for example, let's say a DMU kinematics where the animation has been done so that a particular component, when it functions in a real time, uh, due by seeing the animation, whether we'll come to know what kind of hindrance is occurring, whether the animation, the motion has been occurring in the free space without any hindrance, or do we have any constraints on it. So those things can be analyzed in this workbench in the initial stage itself. So here we have electrical harness discipline workbench. This is highly nowadays it's being used in high data where we have electrical assembly design, electrical part design, electrical harness assembly. So by using these all workbenches, we can design design a harness in a particular automotive, locomotive, or in aerospace industries, and those harness can be taken out and drafted, and it goes to the final production line. So these things can be done, and we have here the piping and tubing these links. Even we can work on these workbenches in the later stages. So, in such a way, we can see the machining simulation. The simulation is a particular part how it can be manufactured in a CNC machines. What are the steps needs to be taken care, and what are the operations sequence occurs. So all those things can be done here. Here we have another workbenches known as ergonomics. So we can insert a mannequin, a real human mannequin with respect to uh, let's say in North America, there are people who are taller and their body index would be on the higher range. Let's say 6 feet is the normal uh, human measurement over there. And if you see the Asian countries like Japan and South Korea, North Korea, and sort of things, we are into a moderate. Height of 5.5 and so with respect to that we can create a mannequin and use this mannequin in the particular component or a model and analyze how human resource can handle those models. So in such a way we have so many workbenches. So down the line with my enormous experience of around 18 years, I'm going to provide a training on the sketch workbench and part design, assembly workbench, as well as drafting, and then the sheet metal design and generative surface design. So these are the some of the workbenches which I'm going to take care of for now, and in later stage, based on the amount of input what I receive from you guys, later I would go for the other workbenches based on the requirement. Thank you, and let's meet in the next class.